Solving word problems using Venn diagram. This time, we will be solving different word problems involving sets using Venn diagrams. So allow me to give you an example. So as you can see here, there is a survey and with its result. This Venn diagram shows students' involvement in two sports, swimming and basketball. So, if 100 students were surveyed, how many students were A, into swimming but not basketball, and the other questions as well. So, the data, the ones that being collected, it's already summarized through the Venn diagram. So take note that when we are dealing with these word problems involving sets using Venn diagram, we are already dealing with a cardinality. So if you try to recall, cardinality is about asking the question, how many? So that means the 100 that you see right now, these are the number of students being considered in our universal set. So there are 100 students being considered. And we have here the data. So S is for swimming and B is for those who likes basketball. So let us try to understand first what's happening in our Venn diagram. So take note that this region in here, those are people actually who loves swimming only. Swimming only, but not basketball. Next region that we need to understand is this portion. So take note that this region here refers to the number of people who loves basketball only. So the word only is actually referring to um, those who loves basketball but not swimming. So if you notice, instead of writing down the elements, the people who would love swimming and those who loves basketball, the numbers that you see right now is the cardinality. So how many people are supposed to love swimming only and basketball only? So there are 30. And then lastly, the region inside, okay, the intersection between the two, that means that it refers to the intersection. In other words, it refers to the number of people. Okay, I'll use another color. So it is an indicator that um, these are the number of people. This is the number of people who loves swimming. And take note of the word and basketball. And then finally, the region outside, just for you to be aware in advance, this portion here, whatever will be placed here, refers to the complement. When we're dealing with bird problems, the complement, these are people being considered in a situation, part of the 100 students, but they don't like both. So that's the meaning of the ones outside the two circles but still inside the rectangle, because the rectangle is an indicator that we are still considering them. It's just that they don't like any of the options given to them. So let us answer each question in here. Okay, so let's try to answer A first. So our concern is A. So we have your example 1 and then A. In how many students were into swimming but not basketball? That means swimming only. And as you can see, it's 15. So there are 15 students who are into swimming only. Remember, if every time we deal with word problem, it has to be in complete sentence. Okay, let's answer B. Into both swimming and basketball. So take note, you can easily identify what you're looking for based from the keyword given to you. As we said a while ago, when we deal with um, operations, intersection is the word and, union is or. So it says that it's both swimming and basketball. That means that we are talking about intersection. The intersection is here, the green region. That means that there are, oops, there are 20 students who were into both swimming and basketball. So common mistake of some students, they just randomly use the word and or. So if you're talking about intersection, always we use the word and. Let's proceed to C now. So how many students were into either swimming or basketball? So it can be any of those, as so that means as long as they choose swimming, swimming or basketball, they are counted. That means we're talking about union. So take note of the keyword here is or. So whatever their option is, as long as they have a sport between swimming and basketball, or basketball, I mean, swimming or basketball, they will be counted in here in C. That means all we have to do is to add all the ones inside the yellow, the green, and the the blue, the blue region, or for basketball. So that would be 15. That would be 15 plus 20 plus 30. So 15 plus 30 is 35. 35 plus 30 is 65. So that means there are 65 students. There are 65 students who were into either swimming or basketball. And then let's have the last one. It says that we're looking for the number of students who were neither into swimming nor basketball. That means they did not choose any sport, whether it's swimming only, basketball only, or both. So take note, our universal set, the number of students that were being surveyed in this problem is 100. And as we all know, the union of those who loves either swimming, basketball, or both is 65. So the orange region now is here, and to get that, all you need to do is to subtract the universal set with the union of the two sets that we have. So that's 100 minus 65. 100 minus 65 is 35. So there are 35 students who were neither into swimming nor basketball. Okay, let's try to answer another problem. Let's have example 2. In a survey of 40 students, 20 use Twitter, 25 use FB, and 7 use both Twitter and FB. And we have here questions. Now you might be wondering, why is it that our first question, for example, is how many students use Twitter only? So what makes it different from our given? Okay, first of all, compared to example 1 and 2, there is no Venn diagram to help us out. So just purely result of the survey. If the indicated answer here or statement is just 20 use Twitter, that means that there are some of them here counted in 20 who uses FB as well. Because it did not say it's not limited only to Twitter. As long as they have Twitter, whether they have the FB or not, they are counted. Okay? So, what makes it different in our question? We really want to know who among these people they all have Twitter only, having Twitter only. Okay? So, first, for us to solve this problem, one method that we can use again is to use Venn diagram. So, we will try to organize our result using the format I presented to you. So, first, you make a rectangle, and then you on the um, upper right, and then two circles inside. Inside our two circles, you label that one as perhaps for FB, so that would be F, and for Twitter is T. So don't forget that the audience will not immediately understand what's the meaning of F and T. So you have to make a representation or statement that will let us understand that that's the meaning of those letters. So we say let F contain the elements X such that X is a student who uses um, FB. And then for T, it's for Twitter. So X such that X is a student who uses Twitter. By the way, you have to really pay attention because this is how you will do your performance task. So to give you an idea on what you're supposed to do. So, as we say a while ago, this is all about cardinality. So let's figure out what's the cardinality of F. The cardinality of F is already given to you. Number of elements of F or FB is 25, while the number of elements who uses Twitter is um oh sorry for yes, for FB it's 25, for Twitter is 20. And then we know that the universal set, there are 40 students being considered. And then the intersection between the number of students who uses both FB and Twitter, which is represented by intersection of F and T, by the way. So that would be 7. So now what we will do, we will begin by putting 7 in its location because we know already the um exact region for intersection. And that would be here. So you put 7. Now, for you to get the number of students who likes FB only, okay, again, to get the number of students who like FB only, you just have to subtract, okay, the number of students who like FB, and you get the number of students who like FB and Twitter. So that's 25 minus 7, meaning you will not count those who has both FB and Twitter to get the number of students who like FB only, who has FB only. And that's 25 minus 7. So that will result to an 18. So you put an 18 in here now. And then for you to figure out the number of students who likes Twitter only, so that means there are 20 all in all with Twitter, but there are again 7 who has Twitter and FB, but we only would want to know the students who has Twitter only, so we need to remove the 7 who has FB as well. So 20 minus 7, that would be 13. So that means it's 13 in here. Okay, now we are not yet done with our Venn diagram. Take note that we need to know as well who among the students here doesn't like any of them. So to do that, you just have to know the universal set. That would be 40. Okay, let's say for you to really understand. So that's number of students who's answered none. Okay, so that means you just have to subtract the total number of students. Okay, okay, how many are do we have? Our universal set is 40 minus the union. Okay, take note, what you need to subtract here is the sum of all those who loves FB only, Twitter only, and both. So 18 plus 7 plus 13. So if you add 18 plus 7 plus 13, so there's a plus here, I forgot. So 18 plus 7 is 25. 25 plus 13 is 38. And 40 minus 38 will give us a 2. So where is the area for those who doesn't like any of the social media sites that we have outside the two circles but inside the rectangle? 2. Now we can answer the three questions. So this is how we will come up with conclusion based from the results. So we say that first, how many uses Twitter only? So our answer is 13. There are 13. I will not be writing it on the board anymore to save time. There are 13 students who uses Twitter only. Okay, again for Twitter only, this is 13. And then how many uses FB only? So there are 18. And then how many uses neither of the two social networking sites? That would be 2. There are 2 students who uses neither of the two social networking sites. Okay, let's have example 3. In a class, there are 30 students. So 21 students like math, 16 students like English, 6 students don't like math or English. How many students like both math and English? So this time, the question a while ago, how many students doesn't like, but something new here is we're asked about how many students like both. So how will we do this? So same, we will be using Venn diagram to answer the problem. by making first the Venn diagram. Don't forget the U and the meaning of the cardinality of our universal set is 30 because there are 30 students being surveyed. Now, we have two sets here, those who like math and those who like English. So two circles with intersection. One is English and one is for math. So now take note, there's no word in our given data, the word only. So that means the 21 students who like math in here, there's also tendency that there are some of them who likes math but English as well. So our cardinality or number of students who like math is 21. And then those who likes English is 16. Number of students who doesn't like any is 6. And don't forget that people will not be getting or understand what it means with our representation M and E. So we say let M contain the elements x such that x is a student who likes English. Okay, I mean math because we're talking about M. So math. And then E, so this is the number of students based from the survey who likes English. Okay, so where will you begin? So as we all know, 6 has its exact location. So 6 will be here outside the two circles, but still inside the rectangle because they are part of the 30 students that we've surveyed. So what do we do now to easily get the result is we just have to add 21, 16, and 6 and subtract it with 30 to identify the intersection. So how will we do that? So again, add 21, 16, and 6 and then subtract 30 afterwards. So 21 plus 16, 21 plus 16 is 37. 37 plus 6 is 43. Oops. Then 43 minus 30 is 13. So therefore, you put 13 in here in our intersection because that's the meaning of the 13. Those are the number of students who like both math and English. So now to get the those students who likes English only, all you need to do is to subtract 16 with 13. And those who likes both. So 16 minus 13 is 3. And then those who likes math only, math is 21, but we need to get the number we need to subtract the number of students who likes English as well. So we only would want to know how many students who likes math alone. So 21 minus 13. So 21 minus 13 is 8. So there you go. So E only is 3, M only is 8. So we can answer the problems now. Again, when you try to do your performance task, it has to be in complete sentence when you do conclusion. So to answer the question, how many students like both in English? So therefore, By the way, the three dots that looks like the edge of a triangle is the meaning of that is therefore. So we say therefore there are 8 students who likes both math and English. Okay, now take note to double check your work, you just have to add everything and it should sum up to a 30. So 13 plus 8 is 21. 21 plus 3 is 24 plus 6 is 30. Okay, this would be our last example, example number 4. In Mrs. Cruz advisory class with 30 students, 20 like mathematics, 15 like English, and 6 don't like math or English. Okay, so there are questions being thrown in. Just double check that it's not repeated. Okay, it's not repeated, so we can solve this now. So start with the Venn diagram. So rectangle first, U, then two circles. Okay, let's try to make a better figure for circles. And then don't forget to represent so that your reader will understand what's the meaning of those letters, capital letters to be specific. So perhaps you can say let M containing the element X such that X is a student who likes math. And then E probably would be is a student who likes English. So we know that there are 6 students who doesn't like math. So you can easily put 6 outside the two circles but inside the rectangle. And then as I said a while ago, okay, I forgot, this is M, this is E. Okay, as I said a while ago, you can identify the intersection right away, those students who like both math and English, by adding, okay, by adding the 20, those who like math, but again, there's no word only, so that means it's not just limited to those students who like math alone, but it can be they like math only, but they might like both math and English. So again, going back, 20 likes math, 15 likes English, and 6 doesn't like. And then you need to subtract it from the total number of students being surveyed or our universal set. So 20 plus 15 is 35. 35 plus 6 is 41. So 41 minus 30 is 11. So next, all you need to do to get those students who like math only, so you just have to subtract 11 from 20, those who like mathematics. So 20 minus 11 is 9. So M only is 9. And then those who likes English only, to get that one, that would be 15 minus the intersection 11. So 15 minus 11 is 4. So we'll double check if our result would result to the sum of the number of students being surveyed. So 9 plus 11 is 20. 20 plus 4 is 24. Plus 6 is 30. So therefore, to answer our question now in complete sentence, but I will not be writing it on my board. How many students like both math and English? So that's an 11. So it's here. So just here, 11. And then, how many students like mathematics only? So this is mathematics only, which is 9. If there is a question about how many students like English only, that would be 4 students.